share my screen here. All right. So let's get to items here. So the items I wanted to cover today are more about classes and objects. So the first concept we're going to look at is a concept called overloading. So this is the idea of being able to do multiple things with the same method name. So if we have two methods that are the same name but have different parameters, this is called overloading. It's kind of like when we create an explicit constructor and a default constructor. So those things are both named the same thing. For instance, if we had another car here method that would create a car with a particular make and model, that we passed it, that would be the explicit constructor instead of a default constructor, which would maybe make a car that had an unknown make and model or something like that. Okay, so if we take a look at this car class, all of our attributes are private, as noted by the minus sign there. All of them are also non-static, so they need to be accessed inside of the class. So make note of that as well. Then we've got a public constructor here, and then we have private methods here for toString, the get make, get year, get speed, all our getters there or accessors, and then we've got our accelerate methods, an overloaded accelerate method, and a break method here. So those are our somewhat our mutators of sorts. Some of them are going to change pieces like our speed in our class here. So that's the car class in a UML diagram. And if we look into here at some of the method terminology, this would be a method definition. So if we're asking about a method definition, this is what we're talking about. The entire method from the header portion up here with the left curly brace and then the right curly brace at the bottom here, all the way through the method itself. So that's the method definition. We've got a method body, which is the portion inside of the braces, left curly brace and right curly brace. And then we have what's called the method header, or sometimes can be interchangeable with the next term, the method signature, which is just the name of the method and the parameters. So that's the method signature, versus the method header is including the entire heading portion without the braces. So the public void, and here it would be public static, like the public static void main string array args, that is a method header. The method signature for that would be main sub string array args, and that would be the method signature for the main method that we typically work with. So those are some terminology pieces. Make sure you understand the different pieces of those. So this first item we'll take a look at here is if we're working with a person class here. This person class has a name, and that's the only attribute we have here. So we've got a name. We're going to set a name when we create a person, and then we're going to get the name with the getter here. And with this particular class right here, as simple as it is, there is no setter. So the only time you are setting the name is when you are creating the person. You can't change the person's name in this particular one. You'd have to delete this person and then create a new person. So it's what we would call immutable. We cannot change the contents of this class. So that's what this term immutable means. You cannot change it. Immutable means you cannot change the attributes inside of there. You have to create a new one in order to create a copy of that item. So if we say person Bob and we say new person sub Bob, then we're going to print line bob.getName. And the question here is, will it compile, and what happens if we compile? Will it compile is yes, it does compile, and what will be printed here is we will be printing a null in here. So So in here, we're shadowing the Bob. The name parameter shadows the name field. So we've got this idea of this name parameter here, and it's the name field here. So what are we doing in here, and why is it printing null here? System out println bob.getName. So let's go ahead and run this inside of some code just to see what's going on and why this is the case. I'm going to go ahead and open up JGrasp here, and we'll get into here and create a new class. This time I'm going to use JGrasp for today because it's going to be a little faster to do some of the things I want to do in here. All right, save this as person.java. Then we're going to go ahead and create a main method in here. And this is how you should really be trying to test some of your code that you're working with now. As we work with some of these things, you should be trying to set up little pieces in main, little snippets there to test, to make sure you've got everything working the way you want to in your program. And or setting up JUnit tests for your particular thing. This one's going to be so small that setting up a JUnit test is going to be a little bit overkill for this. So we've got this idea of null here. When we're returning the name. So why is this that is null? Because we're creating this person Bob, and we're printing out bob.getName. So this name is not getting set to anything, even though we're passing in this name Bob here to that. So why is this? Let's go into that in a little bit more detail. So what happens if we run this piece over here? And we run a bob.toString here. And what we get over here is, actually, let's keep that other piece around just in case we want to run and compare. I'll go ahead and comment it out because I don't want it to affect any of what we're doing down here in this new code. All right, let's compile that. Let's run that. So this time when we do bob.toString, we're getting this person at 4DC63996. What that is we are seeing that it's a person object and it's a pointer to this memory location. So when we do a toString without having an explicit toString in our method, that's what we're going to get, is the memory location. So right now, all we're doing is pointing to a memory location that is set at null. We have not set this actual value correctly using this particular code. So because we're saying name equals name up here. So let's go back into our piece here and see what the next portion is. So this is the answer here. Again, this will change. This one says 6FF because it's another memory location. It's randomly going to assign memory in Java to where it is. So that's going to always be something different for every time you run the program, more than likely. All right. So every class has a default toString method. The string is going to contain the name of the class and the location of the object in memory. So this isn't going to be very helpful, but you'll always be able to call the default toString. Be careful because sometimes if you don't add a toString, you're going to have the default toString as the only thing that runs. So you will get one of these person at 6FF4FF23 kind of outputs if you're not careful and you're not paying attention to what's going on there. All right. So what if we add this new piece to this over here? Let's add in this extra piece into our class. So we'll have a toString in here, an explicit toString. We'll get this person named Bob, hopefully. We'll compile this and let's see if we're running the same piece or println Bob. So we're doing this over here this time. A little bit different. All right. So this is going to be the next piece we want to test. And in this case, we're going to get this person name null because we're still not being successful in setting this person's name to Bob. Okay, so why is this? Keep moving down here, and we're going to go into here and change this up. Let's grab the entirety of this just to make sure we've got this in here. And we've noticed we've changed how we're doing this here and what we're adding into here. We've changed this name to N here. So let's go ahead and change this code in our other side over here. I'm going to go ahead and change all of this as such. We have that. Then we're going to run this again. Let's go ahead and find what we wanted to print out here. Print line Bob. And we'll demonstrate this last piece in here. I think this is the exact same line here. Yes. Okay. So we'll leave that as is. All right. Let's run this. Oop, I got an extra end race because I've got an extra declaration of my class. All right. Pull this out here, compile it, and run it. Okay. So now we are getting person name Bob because we are setting name equal to N, which is this new value that we're passing into it, Bob. So this is where, again, this is key that it was setting the value to itself, and that was going to be a problem because it was setting itself to null because it was creating that same reference to, and it was kind of coming into a circle and setting it to null. So make sure when you're doing your class constructor and your creation of and using your setters to create something that you are doing this in a way that you are explicitly passing it different variables and not referring to the same memory reference. Because if you do refer to the same memory object, it's going to just spin and not going to set anything the way you think it's going to be setting it. So now we're finally getting this person named Bob. Print methods will automatically call the toString method if you don't do anything else. So that's why this works. We're getting this to pass it the toString, even though we didn't explicitly call the toString. This is how the print method works, is to call the toString. So when we're doing this print line Bob, it's calling the toString method over here. So make sure you understand that that's going to happen if you don't do anything else. All right, so let's go out here. Let's run this last set of code here. What's going to happen with this? Comment these out again. Let's see what we get as an output here. And here we get a false. And that's going to give us this idea of a return of false in there. And that's going to be the answer here. So what we get when we say person one equals new person sub Bob, person Bob 2 equals new person sub Bob, Bob 1 is equal to Bob 2, yet that is false because what we're comparing here Bob 1 equal Bob 2 is we're comparing the memory locations. So that's going to be false, even though the values of these are the same. So it doesn't matter. And at this point, there is no default equals dot equals method. So it's going to go to the default and it's just going to check to see if these values are equal in memory. So it's going to look at the two memory objects and see if they're in the same memory location, and they're not. So that's what it's going to print. So if we did a print line of Bob 1 and Bob 2, we would have two different memory locations. Let's do that just to show this. So if we did a system out print line Bob 1 and Bob 2, we should get two different memory locations in here. Oh, let's see. We now have an explicit item here. So let's go ahead and comment this out real quick, just so that we can have it run the explicit toString. So now we can see these are two different memory locations for this Bob1 and Bob2, and that's why it's printing out what it's printing there. So, all right, so next item. So we keep going here. The next piece we're going to do is add a dot equals here to this question here and see if this dot equals. So let's go into here and do a comment of this section. All right. Bob1 and Bob2, they're new people here. Bob1 dot equals Bob2. Let's see if that's going to happen. Let's see, was that what we wanted to do? Yes, okay. Let's go ahead and see what happens here when we run this. And over here, we're still getting false because Bob1 does not dot equal Bob2. Again, that's a memory location comparison. So we're going to get that false. And again, this is saying all classes get a default dot equals method. It just uses equal equal. And so it's going to run that same thing that we were running before on the check. So now we need to run a dot equals method and create a dot equals method. So let's go ahead and grab the rest of this code here. I'll paste this into our existing code. So this is writing a dot equals method for this person method. So we've added an item here. We've added an int SSN in here, and we have our existing name, but we've added this extra field to the person so that we can have uniquely identifiable people by SSN. So in here, when we create a person, we're setting it to their name to the name, their social security number to this number, and then when we're doing a get name, we're going to return the name, get SSN, return that SSN. We've got the toString where we say person name so-and-so, and then we've got the dot equals method here. So we're going to work with this other person and then this person. And so if we've got this or name dot equals other dot get name. So we're working with this, we could say this dot name, or in here, it's name dot equals other dot get name. So we're going to want to see that, and SSN is equal to other dot get SSN. So this is the dot equals method. I would definitely understand how to do this on the exam. This is one of the types of methods you will definitely have to be able to write yourself. I can guarantee you on the final exam, we're going to ask you to write a dot equals method for a particular class. So this is definitely something you want to store and pay attention to and study and make sure you understand how to properly write a dot equals method. And you'll be having to do this on the fly on your own. So remember the nomenclature here and how to do the references to the particular attributes here for the final exam. All right. And we're comparing all the fields here to make sure they're equal. All right. So now if we run this piece of code, what are we going to get as a printout here? All right. Let's clean this up a little bit, and then I'm not going to clean it up too much, but I just want to get it a little bit cleaner there. All right. So we've got a bunch of true and falses. What are we looking at here? So we've got over here, Bob1 is new person. So Bob and 1, then Bob2 is going to be a person that has the same name Bob, but their SSN and their SSN is equal to Bob1 is equal to 1 as well. So that's going to be a double entry in our system of people. And then Bob3 equals new person sub Bob, comma 3. So that's going to be a second new person. Then Bob4 equals Bob2. So Bob4 is going to point to the exact same memory location as Bob2. So over here, Bob1 dot equals Bob2. So these two should be equal and that it is the case. They are true because both of these guys have the same information here, and we're calling our dot equals, which checks the name and the SSN, and those are all the same in those. So they're the same up there. Bob1 dot equals Bob3. So Bob3 is here, and that should be false, and that's what we're getting. Bob1 dot equals Bob4. This should be true because we've got Bob1 equaling Bob4, which is the same value as Bob2, and those two values are going to give us the same thing. Over here, Bob2 equals Bob4, and that's going to be true as well because we just set these two as the same thing over here. Then we've got these equal, and we've got Bob1 equal Bob2, and that is going to be false because these two are going to have separate memory locations. Bob1 equal Bob3 is going to be false, as we expect it to be. And then Bob1 equal Bob4 is also false. But when we go to Bob2 equal Bob4, that is actually going to be true because these two were pointing to the same memory location because we created Bob4 by pointing Bob4 to the same thing that Bob2 is pointing to. So make note of this. These are the subtle little differences, but they come out differently. So, all right. So the toString piece, this is another piece that you'll definitely want to be able to understand how these work. Again, there's the default and then the explicit toString and equals. So providing toString and equals methods would be a routine part of any time you develop a class. So you want to make sure you develop explicit ones, otherwise you're going to be stuck with the default ones. So no toString methods can complicate testing. No equals method may lead to sneaky bugs or broken equals method because it's going to do the default one where it's comparing memory locations. So make sure you write and don't forget to write your equals and your toString explicit methods in your classes. All right, so we've got this car that we wrote earlier. I'm going to go ahead and take this code here and then grab it, and let's see what we've got out of here. And we'll load our car that we had earlier. And I loaded these down from the website earlier. Then I think I've even got this car main, so we can actually take that and run that. So we've got car and car main. And so the car main, I think it's the same. Yeah, let's just copy it in just to make sure. All right, compile this. And then let's go ahead and run this. So what are we having here? We're going to run this and our output is that. So what is this doing though? We're creating a result int and we're going to say string s equals hello. We're system out print line s, so that's the first hello there. Then result equals nonsense1 sub s. So what is nonsense1? Nonsense1 over here is not going to do a whole lot. So nonsense1 is in here. We're going to pass it the word and word plus word. So word plus equals word. So this is going to add the word to itself. And then we're going to return the word length in here. So nonsense1 sub s. So if we pass hello into here, it should be 1, 2, 3, 4, 5 as the length of the word. So that should be result equals nonsense1. So result equals 5. And then we're going to system out print line s again. That's going to be our second hello. Then we've got our other pieces in here where we're going to do some extra items here, and we're going to say car Ford equals new car Ford 1992. So the make and the model of this are the make and the year are, it's a Ford. It's that was created in 92. So system out print line Ford.get speed, and it's going to give us the 0.0 because we have not set any speed on the car. So this car by default gets a speed of 0 when we create this one with the two parameters here that we've passed. We've only sent two parameters, so it's going to give the make and the year over here, and it's going to set those to the right one, Ford 1992, and then speed 0. So 0.0 is going to get stored because it's stored as a double for the speed. So we're going to get this, and then we're going to come over here to this item of result equals nonsense 2 sub Ford, and we're going to pass the car into there. So nonsense 2 of the car, and we're going to accelerate the car. So the accelerate comes into here, and it's going to call the accelerate method, which over here is adding 5 to the speed. Unless it's the max, then it's going to stay the max speed. So we are not there, so it's actually going to add 5. And then over here, we're going to system out print line Ford.get speed, which will be the 5.0, and that's why we get that. Yeah. So this is a run through of some of the items in this car class here. Got a few things here. Simple little car class. You can accelerate and you can brake, and you can get the speed of the car. All right. So again, this idea of mutable and immutable types, that person that we created was an immutable type because we couldn't change the name of the person once they were created. And a mutable type is an object field can change over time. So you have to be careful that our methods don't accidentally modify mutable objects that are passed as arguments. So we want to make sure we're not doing things in improper ways. So that's, again, when you're passing in parameters and arguments in, you're going to want to make sure they're differently named than the actual attributes, because otherwise you're going to get confused and bad things will happen. So make sure you're aware of that and name things appropriately, or appropriate to the difference that you want to have. All right, let's get into the next thing, which is this houses lab. And then the final thing we'll cover in class today will be the idea of some of the final PA. I'll go over a few things to kind of help you set that up and figure out how to get some of that running. All right. So you can get started on that, because again, that's not due this Sunday, but it's due the next Sunday, and there's quite a bit of work to it. Next week, next Thursday, will be a complete day where I'm just going to have office hours that morning. So if you want to come on and ask any questions, try and get something started before then, and you can use Thursday to use as a day to ask questions about the final programming assignment. Again, that is worth 5% of your grade, so it's definitely not something to just punt or kick off because it's going to be half a letter grade on there, and that can be the difference between the C and a D, C minus, because at this point with the credit, no credit, you definitely need the C on that to get that credit on there. All right, and lab 23, we're going to actually work with some, hopefully this will be a fun little lab, because it's actually going to work with some graphics here. We're actually going to finally get to see something on the screen for a change. Instead of all these ASCII characters, we're actually going to see it draw some things out on the screen for us. So we're going to work with some objects here. We're going to draw some pictures. The standard draw class here is what we're going to be used. Robert Sedgwick and Kevin Wayne at Princeton developed this class, and it's a lot of useful methods that make it possible to create small, simple drawings in Java. You can actually get pretty complicated things going on in here as well. The documentation's available here, so you can kind of see what the class does and what the Java doc for it is, and some of the attributes that are available, and then also some of the methods that you can do in here. And you'll want to come back to here to reference to understand how these things are being drawn and the coordinate system that this is using to draw these particular items. So make sure you understand some of those. I've included the really essential ones over here, so and copy that Java doc here so you don't have to keep going back there. But if you're interested in learning more about it, you can go see the complete documentation there. Let's create a folder for our work today. I'm going to create one on my desktop called Lab 22. All right, let's do this. Clear out my desktop over here. It's getting messy. Lab 22 is folder. I'm going to save these into here. Download link file as, and I'm going to save this into my desktop. I'm going to right click on this, download link file and save it on the desktop, and download link file and save it on the desktop. Then I'm going to take all of these and I'm going to move them into my Lab 22 folder. Remember, these three need to be in that same folder in order to compile and work together. So if you're creating this at home, you'll need to make sure you're putting all three of these into the same folder. All right. So we want to open up Draw Demo in JGrasp here. Let's go ahead and open JGrasp back up. And I'm going to go out here and refresh this. I've got a Lab 22 folder, and I'm going to open up this Draw Demo here. All right. So I've got this Draw Demo open here. Let's go ahead and I'm going to put this 50-50 so I can see both things at the same time. Then I'm going to continue on with trying to finish out this class, okay, and see what happens here. So I'm opening up the Draw Demo, read over the code here. What this is going to do is it's going to draw a line at 0.2.2. So what is this line? It's double x0, y0. So this is the x, starting x and starting y. Then it's going to go to a point that's at 3.3.5. So it's going to go from 0.2.2 to 0.3.5. So 2, to 1, 2, 3, 1, 2, 3, 4, 5. So something like that. That's going to be the angle of that one. Then it's going to draw a rectangle at 0.6.6, 0.1.3. So what is that? That's x and the y. Draws a rectangle of the specified size centered at xy. So it's going to be centered at xy. So make sure you're understanding that piece, that the center of the rectangle is going to be the point. So this point, 0.6.6, is the center of it, and it's going to mean it's got half the width is going to be 0.1. So it's going to be 0.1 away from this 0.6.6. So it's going to be, the rectangle is going to go to 0.7 and 0.5 over here. And then it's going to go half the height. So it's going to go 0.3 up. So it's going to go to 0.9 and then 0.3 down here. So that's how the rectangle is going to go. 6.6 is going to be the center, and then it's going to go to 3.9 and then 5.7 over here. So those are the kind of parameters of this rectangle. Make sure you're understanding how this works, because it's half the height, half the width, and then it's going to be xy as the center of the rectangle. Then over here, we're going to do a filled circle, and this filled circle is going to be at 0, 0, draws a filled circle of the specified radius centered at xy. So the center of this circle is going to be 0.1, 0.9, and it's going to have a radius of 0.1. So 0.1, 0.9 with a radius of 0.1 around it. All right, so let's compile this, and then let's run it, and we're going to see. Put my window over here, so I got to drag it back here for you. Okay, so here's where we've got this. So we've got this 0.1, 0.1 circle, or 0.1, 0.9. So 0.1, 0.9 is where this circle center is, and then it's a 0.1 radius here. So that's the circle, filled circle we're drawing. The line here is at 0.2, 0.2, and it's going to go up to 0.3, 0.5 over here, 4 or 5. So these, if you had a scale of this and you had a grid on here, this would be, you can see kind of where 1 is about here. So it's about this much space on, maybe about 200 pixels on the screen is a 0.1 in this scale here. Then we're going to have this centered at 0.6, 0.6. It's going to have this out to 0.7, over to 0.5, up to 0.9, down to 0.3. So, and then we can see 0.9 is here. This 0.1, 0.9 is the center, and you can kind of reference that over here as to the top of the rectangle is at the same point as the center of the circle. So that's what this class is doing and how this class works to draw these pieces. So let's go. 0, 0 is located in the lower left corner of the drawing, and 1, 1 is in the upper right. So that's the keys to this as well. So let's kind of go ahead, and I'm going to go ahead and create a PowerPoint here to kind of express that so that we can kind of all right. So we can kind of understand this as we're creating a shape here, and we've got this grid, and our grid is going to go, that we're drawing with, goes from over here in the bottom corner. We've got 0, 0. And then out here at the top corner, we've got 1, 1. So that's our kind of canvas we're working with in here. So this 0, 0 to 1, 1 area. All right. So let's go to draw demo here, and let's modify it to place a small filled rectangle in the upper left corner of the drawing window. So let's try that. We're going to standard draw filled rectangle in here. And we're going to put it in the upper corner of the drawing. So let's go to 0.8, 0.8. We'll go 0.1, 0.1. So we'll make this filled rectangle an actual, actually let's go 0.2, 0.1 maybe. Let's see, so that'll get us out there, 0.2, 0.2. Yeah, let's do that. All right. And when we run that, we should get this rectangle that is now filling up here into the corner, because it's actually a square, we'd call it, because it's a equal-sided rectangle. But that's the idea here of getting that into that upper right-hand corner. So let's say small rectangle. So let's go to 0.9, 0.9, and we'll say 0.1, 0.1. And let's run this again, end run, and then we'll run a new one. And this is going to give us a small rectangle up here in the corner. So we're not overlapping anything. All right. And test the modifications. They worked. Okay, so now let's open up houses.java. And what we're going to be trying to do is create this particular house shape here. So read over the provided code, then run it. I'm just going to go ahead and compile this and run it. What we're going to get here from this is this drawing of a door here. So we've provided you so far the items that are going to create a door. So we've created a draw door method here. We're creating a knob inside of the door. And so here we go. Where is it going to do? It's going to draw a rectangle here at 0.2, 0.5. So we're passing in 0.2, 0.5 into this rectangle, which is going to draw a rectangle at 0.2, 0.5. So 0.12, 0.5 is the center of this rectangle. And this rectangle is going to have a width of 0.05 right here and a height of 0.1. So it's going to go 0.1 either direction here. And then we're going to have a knob radius of 0.005. So it's going to do a filled circle at X, which is, again, this 0.1 that we passed it over, or 0.2 that we passed it over here, 0.2. And then over here, we've got this knob offset that we're going to take it at minus 0.1. So instead of going out to 0.2 here, or going out to just 0.2, we're pulling it back 0.01. So we're going to come out here and then pull it back 0.01. And then we're going to go to y and the knob radius. So the y value here is 0.5. So this is going to be at the center, same spot as this rectangle was centered, but we're going to offset it a little bit. And then we're going to have the radius of the knob here as 0.005. So that's what we've got there. And that's how it's drawing that particular item. Just this draw door piece. So that's going to draw us a door. So what we want to do is add a method here that is called draw house, so that you are drawing the rest of the house here. And so you're going to want to create something around that door that is looking like this. Again, it should take two double parameters named x and y, and executing it should have a house that looks like that. I'll go ahead and get started here for you. Then we'll let you finish out the piece for the homework here. This one is not going to be very heavily graded. I just want to see that you can get something out there. It doesn't have to be perfect. I'm going to be grading more the visuals on this than anything else. So don't worry about the AutoLab grade. As long as what you're submitting to AutoLab is passing and compiling and check styling, everything is good. I think I had tried to make it where it would check the difference between your picture and my picture, but people were moving them slightly or things like that, and so it wasn't coming out exactly right. So if you can get that portion, great. If not, don't worry about it. I'll be grading this visually. Make sure when you're done here, you want to save your output from your item there as a JPEG. So let's go ahead and do this. So at the end of here, you'll want to save the image through the file menu, and you want to save it as up here. If you come into here, there's a file menu and you can hit save, and you can save this as a JPEG. So you can save this as house.jpg, and that will save this to your desktop as a JPEG file. So make sure you do that so that I can have that, and you can submit that into Canvas. That's the piece that needs to be submitted to Canvas, and then the rest of it gets submitted to AutoLab, and hopefully those will come out correctly. So let's see what we've got for this draw house. So our draw house, we're going to want to do a draw house where we create some parameters and some other things. Let's go ahead and create the method here. And if we start in here, we're going to do draw house. And we've got nothing we're returning, so let's go ahead and save that. And let's come into here, change this to all right, that lines up. That was bothering me. Let's go ahead and come into here and clean this up there. All right. So if we create our draw house, we're going to pass it an X and a Y coordinate that we want our house to be at. And then we're going to want to do something with this. So let's draw the door for our house. So let's do a door for this house. So we're going to draw this door at X, Y, and then we're going to have a door height. I'm going to set up 3 constants here that I use inside of my method here. So these are going to be the constants I use for the total width is 0.1 of the, and then the door height is 0.1. That's the height of the door. Then the bottom height is 0.2. So we'll see what we're going to do with this bottom height. So we've got this draw door, and we're going to do it to the X and the Y, or whatever we're passed in. So we're going to center all of this on the door. So we're going to pass in an X and a Y to the door, and then we're going to say we want to, we're going to say the y is minus the door height because we want to have it offset divided by 2 because the door height is 0.1 total, but we want to go half of that height, which that way we can get the half height for where we want to do some of this stuff. Okay, so that's going to draw our door. Then we're going to draw the bottom of the house, which is the rectangle at the bottom here. So we'll set this up and we'll draw the rectangle that is the bottom of the house. And we want to start this rectangle at x comma y with where we take the total width of the house divided by 2 and the bottom height divided by 2 because we've set up these values here that we gave you. Total width of the house should be 0.2, so we've got that total width, but we want the half width here because we're dividing things in half to pass these half widths to the rectangle and the circle and other methods that the line methods that we want to do into there. So let's go ahead and do this. Let's compile this. And then let's run this. And right now, all we're going to do is get this particular piece done because we're only at this point still drawing the door. So let's go ahead and change this now. Instead of drawing door, I'm going to go ahead and draw house. And this is the houses we want to draw. We want to draw 3 houses. By the end of this thing, we're going to want to draw the first one at 0.2, 0.5, then we're going to want a 0.5, 0.5, and 0.8, 0.5. I'm going to comment out the others for now because I only want to do the one. And let's go ahead and run this. And now I get this particular output here as what I'm getting for my first house. This is the base of the house, and it's going to have the door with all that offset business. The next thing I need to do is start drawing the roof on the house. So that's the piece I'm going to leave up to you. So you want to take reference points and then draw 2 lines, one line from here to here, the next line from here to here. So this is the half width here. This is going to involve a little bit of geometry / math there to kind of figure those pieces out. Hopefully it's not too difficult of math. It's just going to be drawing this roof portion. So you just want to do that last 2 pieces of drawing the roof. If you're getting stuck on that, let me know, and I can give you some more hints on the Piazza or via email. So I'm going to leave this as it is here, though, and then I will go ahead and move on to talking a little bit about the programming assignment. So let's go ahead and get out of here. I'm going to go back to here and the 7 little words programming assignment. So within here, I think I went over the game. You can go here and actually play this. It's also a phone app if you get addicted to this game like I did for a little while. It's actually a fun little distraction of a game. It's nice to play on a car trip because it doesn't really require you have too much connection to your internet to play it once you get the initial game downloaded and then the particular day's puzzle downloaded. It really doesn't, you can kind of be offline and play it. But the game basically is one where you're working with these word pieces and then hints over here and then the solution. So what we're going to do is we've broken this out. So this is a single player game. You want to guess the 7 words that correspond to the 7 provided clues. So kind of like a crossword puzzle. No time limit, no penalty for incorrect guesses. So you can just keep guessing and trying to put together stuff in the game. So you have the 7 clues and the length of the corresponding word answers. So that's going to be how you kind of figure out what to try in there. In addition, you're provided with a group of tiles, each of which contains a slice of one of the words to be guessed. So all of these items in here are partial slices. So this ANC, LA, CO, IR, those are all slices here. So to make a guess, the player selects tiles in order and presses the guess button. When a tile is selected, it is temporarily removed from the board. After a correct guess, the tiles that constitute the guess are removed from the board, so you can't use those tiles over again. After an incorrect guess, the tiles that constitute a guess are returned to the board, so you can use them for a guess again. Hints: at any point, the player can request, with no penalty, a hint for a particular clue. Specifically, the player can ask for the first letter in the word associated with the clue, the first tile in the word associated with the clue, or the answer. So you can just, in our version of the game, you can actually ask hints to where you get the entire answer. So shuffling: at any point, the player can shuffle the tiles. That might help you see a pattern better. Over here, they've got that same kind of thing where you can do a shuffle and it'll shuffle these things. There's no penalty for this. It allows you to kind of rethink what these things are over here. Then for us over here to create the game, so we're creating the game as an author here, and the author creates a single text file that contains 7 dash delimited records or lines. The first field in each record or line contains the answer, and the second contains the clues. So in here, we've got a sample game file. So here we've got class, an intensive definition of a set, expression, a valid construct that can be evaluated, indefinite, not known in advance, iteration, one passed through a loop, object, an instance of a class, operator, a symbol representing an operation, and static, belonging to a class. So these are definitions in computer science. These are the words over here on the left, and on the right here are the clues. So you would get these items into here, and you would load them into our game. We've written some portions of this game for you. They are the game board, the tile, the guest field, and the utilities. And so what you need to do with these are .class files. You'll need to download these files to your desktop, and they are .class files, and just put them in the same directory as your files that you'll be working on. So I'm going to go ahead and do this. Right-click these all, download these, and save them. And then I'm going to create a new folder called FinalPA, and I'm going to put all of these files into there. Let's move those in. All right, this is giving me a tough time doing this. Let's see. All right, there we go. So I've gotten those all off my desktop into this folder that's on my desktop. All right, so now I can go load this, and I'm going to go ahead and load this into JGrasp, because this way it'll be easier for you to kind of see these quickly. Actually, you know what? I will go ahead and do this in Eclipse just to... no, let's do this in JGrasp. It'll be faster. All right. Let's go to the desktop, FinalPA, and I've got all these items in here. I'm going to close these guys out in JGrasp, and then I'm going to go back over to my specification here. Let's go ahead and move this 50-50. All right. Graphical user interface. Last is a utility class for reading files. Yeah, okay, so we won't address these tile and guest fields directly. They're going to be used by the game board itself. So the other purposes of the classes should be apparent from their names. We've got a main class. So what we're going to want to do is set up a main class here. We'll do file new Java. Oop, not a plain text. Let's go ahead and kill that. File new Java. And then we're going to go public class main. And we'll go ahead and set that up. Main class for FinalPA. 7 little words. Author. Version. I have a GNU honor code. So this is the kind of stuff you want to try and get done this week, is the little simple things like this. Construct a game info object using the name passed to it as a command line. So you're going to want to set up in here. If I open this in a new tab, I can see it better. So we've got this thing here. I want to set this up. I'm going to actually probably put this as a PDF in the linkable so you can click on it and go to a PDF, and that'll hopefully allow you to see it a little bit larger. So we want a main, so it's the main class. This main class is actually called, it's 7 little words. So actually the main class here is called 7 little words. Okay, so, and that's over here. And we're going to have in here, we're going to have this main class for 7 little words. It must construct a game info object, and then it's going to have, that's going to get passed to it, and it's going to create one of these, and it's going to construct a game board using that, and then show the game board, calling it set visible method and passing it the value true. So that's what we're going to do with this method. It's going to be a pretty simple one, but you'll want to do some things in here. This is going to have a main actual method in it that we set up. You can see it's got a public static void main string array args. It's going to do some things. So we'll go ahead and save this. So we want to save this in 7 little words. This is going to be the main class that we have. Go main at param args and line arguments. And that'll be it for this. And we can create game board using game info object and set visible true. Okay, so this is something we'll have to do with this. So I'm just going to leave a little comment in there. That's going to be what you need to do with this main class here. The slice class. So we need another class here that's called the slice class. I'm going to do public class slice. This is going to work with the slices of the words here. So slice can be either used to state or in use state or the unused state. When a slice is in the used state, its toString must return its text. However, when it is in the used state, it must return the empty string blank. So it must be possible to put a slice in the used state by calling its use method. On the other hand, it must be possible to put it in the unused state by calling its reset method. Its is used method must return true when it is in the used state and false otherwise. So this is going to kind of keep track of your slice if it's used or unused. So the other thing we're going to do is we're going to need to get some attributes in this class. Go ahead and do this. Nice class for 7 little words. And this is going to be author version 4-2620 JMU honor code provided. All right. And I'm going to come into here and I'm actually going to create a used, which is a Boolean, and it is private. So it's Boolean used. And I'm going to get a private string text. And those are the attributes here, and I'm going to label them as such. And then I'm going to come in here and I'm going to go constructor. Then I'm going to go methods. All right, and I like to give these 3 sections to all these. So let's go ahead and do the slice in there. We're going to do that. I'm not going to create any of these right now. And then I'm going to move on, and I want to move on to the next one that we're going to have to create, which is the word utilities class. So this is public class word utilities. I'm going to create that. And this class, the only public method in the word utilities class is slice. Okay, so the rest of them all are in the word utilities are all, it's only got this one slice method. So we've got a method in here, public, and what are we returning? We're returning a slice array, and we've got it passing, and we're going to have it be public, and it's static. You can see that because it's got an underline on it. Slice array, and then we're going to say slice, and then this is being passed a string. It's called word. Okay, so this is what's going to happen in here inside this method. So this is the changing of this UML and translating it into the method here. So you definitely want to be able to do this particular skill and be able to do this particular thing. So let's go into here, and we're going to call this word utilities. Author, my name, and then at version. All right, we'll just leave it at that. So I'm running out of time here. I'm just going to go ahead and save this. Then I want to do the last class here that is the word clue, or the next class in here is the word clue. I'm going to go ahead and stop here because class is almost over here. And we've got 2 other classes in here. I'll work on some of these next week as we build out the rest of this, just so you can kind of get an idea. So hopefully you've gotten an idea of what this entails. There's a good amount of stuff to write in here. Over here, it gives you a breakdown of how to write this piece, write the slice class, write the word utilities class, and then come down into here. I would recommend that you try and get to probably step 9 in the 21-step program here. Try and get down to about step 9 by Tuesday next week, because if you don't pace yourself with this, you're not going to get this done well by the time it's due on Sunday next week. So you should be trying by next Tuesday's class to try and get through some of these other pieces in here, at least down to the idea of line 6 or so here, so that you're getting through the word utilities and the slice classes. That's the pieces you really should be able to get through yourself. These 2 classes are pretty straightforward. If you can get to those, that would be a good idea to get done, especially getting that slice class done. It's not too much into there. So I would try and get that done this week to get those pieces here down to at least 4, which is the down to the word utilities class. All right, so that's all I wanted to cover today. Hopefully that all made sense. And if you have any